It's a while since I've taken a look at some LED neon, and by neon I just mean it's styled as neon tubing because it provides a very linear glow like proper neon tubes. But it's worth taking a look at this one because it's different from the other ones. The other ones tended to operate at low voltage or were just a fixed colour at mains voltage. But this one's actually colour changing, but does operate at full mains voltage. In the case of America, it takes in 110 volts. In the case of Europe and Australia and other countries with similar voltage, it's 220 volts to 240 volts. And it actually puts that out to the tube as well. So that means that the current is much lower. Each metre of this tube is only drawing, and I tested this, it's drawing about 20 milliamps for a single colour. Or when you go full white, it draws about 50 milliamps. But you can cut it every metre, and by the time if you do the maths of what this says, it says it's rated for about 750 watts. That would equate to a worst case scenario. You could run up to 50 metres of this from this little box without any additional power supply, which is quite handy. But there's a downside to that. Let me plug this in and show you. So I'll plug it in. And let's see if I can make it flicker for you by choosing individual colours. Is it going to flicker? Is it going to do? No, it's not. That's pretty good. Especially if I turn the light off, it would be great because, okay, rightio. It's not going to flicker for us. I really want to flicker now. Oh, I've managed to get a wee bit of flicker. I've managed to get a bit of flicker. The whole point is that this is phase angle controlled. It's running on fully rectified AC, so even when it's a static colour, it is basically pulsioned off, just like the standard sort of mains voltage LED tape. The inside of it looks like this. I have stripped some of the end off. It has, let me zoom down on this. It has about, I think it's about 30 LEDs a metre. Is it 30 LEDs? I might have to actually calculate it. Just give me a moment. I'm just going to check that. One quick measurement and computation. It's 60 LEDs a metre, so that gives quite a linear glow along the length. This is not going to be as bright as a single colour DC one where they're running the LEDs at a fairly decent current, but it's got the advantage of simpler driving, and it's got the advantage of you can run much longer lengths from the power supply. It comes with a remote. The remote's fairly versatile. I got this a while back. I tested it. The remote was flat. I don't know if I've had something sitting on it or if it's a fairly high quiescent current, but it takes triple A cells inside, and they had run down. Maybe it had been squished under something though. It offers dimming. This is where, if I zoom out again, this is where the strobing may show if I actually dim it down, because it'll spend less time. Oh, let's point it at the remote. Is this going to... Oh, it's not too bad actually. But it offers dimming down to quite a low level, and that also controls the colour changing effects. Let me just get this up to the end and show you the colour changing effects, which are, some of them are just awful. That's just very fast cycling. That is colour cycling. Oh, a little bit of a pulsive modulation, pulsive modulation, phase angle control there as it cycles through the colours. This one is strobing. This one is just cycling in colours. That's just awful. Let's just stop that right now and go back to white, which is a very cold, bluey, greeny white. The blue and green are outshining the red LEDs in this. What else can I say about this before I start opening it then? Not a lot. It has bus bars inside it. If you take the end cap off, which exposes live connections, there are 4 bus bars. You've got the common positive, I'm guessing, and then the red, green and blue will be switched down to the negative to actually turn them on. And you can usually join this stuff end to end, although these bus bar wires are very, very small. It's also worth mentioning that as it came, it's been sealed with that sort of silicon goo, and they've also wrapped cling film around it, saran wrap, this sort of clear plastic wrap. And this box was also wrapped around with the cling film. I don't know why they do that. It's fused onto the plastic. It's almost to me as if it's like an extra defense against people opening it up. We shall open it. But the silicon doesn't stick very well. Let me demonstrate. I've not tried this yet, just in case it never went on again, but this, when I took the tape off it, it was all sticky and gooey. Yeah, it's not stuck, and it's sticky because the silicone they've used has reacted with the plastics. It's not the correct thing for the job. But you can see the prongs in there. So normally with this, I'll just make sure this is unplugged before I grab a hold of this. Do I have my long wrist pliers here? Let me just look for my long wrist pliers. Normally with this, you've got a strip like this that you can position into the end like this. Push it up the end of those bus bars, those spikes. It is just basically jamming spikes in. Make sure there are no obvious shorts. Shove it into this again, and if I plug it in, it should work again. Or it'll go bang, one of the two. You have to get the pliers the right way around, particularly at this higher voltage. Yes, it works. Okie dokie. Right. Let's open this box and take a look inside. In fact, you know what? I will just pull that off for that, and I'll chuck this out the way at the moment. So let's slit their cling film. And at the other side, I think I've peeled most of it off, but I shall slit it anyway because there's no harm. What am I expecting here? A circuit board with a discrete rectifier on it. A bridge rectifier made of 4 diodes maybe. Some thyristors in the output. Hopefully it's not just a standard Christmas light controller, though to be honest that would have worked as well, the standard Christmas controllers. I took a similar unit apart for LED tape, and all it did was chase it along chase the sections of LEDs along the run. It works just like a Christmas light controller. 4 screws out. It's a smaller circuit board than I expected. It has a large rectifier, which makes sense because they commonly use that embedded into the plastic. If you've seen the LED strips that run directly from the mains voltage 110 or 240, you'll often have seen that you've got the plug and then it goes into a sort of moulded blob and then it goes onto the tape. The moulded blob usually has one of these big chunky rectifiers, so it makes sense they've used the same one. I'm guessing these are thyristors. That looks like a resistive power supply. Well, that is a hot resistor. Yep, that's why the case was getting hot. Smoothing, very simple circuitry. Fuse, that's nice. There'll be a Zener diode. Let's take a look at the circuitry. One moment, please. Okay, so let's explore. We have the bridge rectifier up here and we have a main current limiting resistor. That leads down to a combination of a Zener diode to clamp the voltage, a smoothing capacitor, and then a resistor leading to another smoothing capacitor to provide a very stable supply to the microcontroller, which then switches what appear to be 3 standard very low gate current thyristors, TP4M, via 3.3K resistors. Now, if I bring in the schematic here and we zoom down on it, do you know what else I'm going to do? I'm going to turn on the solder iron because I have an idea to have a little experiment. So I shall zoom down onto this and grab my pen. So here's the incoming supply. Things that are worthy of note. The neutral is on the wrong connection effect because there is a fuse, but the neutral's on the wrong connection for that. Ideally, it would have been good to have that in the live connection. But it goes through the fuse, and there's another thing worthy of note. Although the fuse is mounted on this side of the circuit board, on the bottom of it, there is a zigzag fuse, but it's actually got a wee solder double pad arranged at the end. So if you bridge those 2 solder pads, it introduces a improvised fuse, or at least a thinner track that may blow earlier. It's a bit ham-fisted, but you know what? It's better than nothing, I suppose. So it's got a fuse. It goes to one of the inputs, the bridge rectifier. The other goes to the other input. That's full mains voltage, let's say 110 to 240 volt, depending on the model. The main factor here will probably be the value of this resistor and the LED tape itself. I've shown a little leg going up here. I shall show that afterwards. I left it out deliberately just to keep this uncluttered. So the output from the positive side goes up, and this is full wave rectified, but unsmoothed. It's the full mains voltage basically up here. Rectified mains voltage. So it's quite high and nippy. The negative rail down here is the negative for all the circuitry. We've got a nice beefy, this looks like a 2-watt resistor, which would make sense, maybe even higher. It's 51k, passes about 5 milliamps on 240, and therefore is dissipating about 1.1 watts of power. It goes down to the Zener diode, which is 5 volt. There's a decoupling capacitor across that. There is a smoothing capacitor. There's the resistor and another smoothing capacitor. These are just components that are just designed to provide a slowing down the current, so to speak, to provide a smooth, ripple-free supply here to provide stability for the infrared receiver and the microcontroller. I think the microcontroller might be more stable than the infrared. Not sure which is the most sensitive to that. And ultimately, that is it. The only other thing that's worth adding, and I'm kind of regretting drawing that up there now. Tell you what, let's bring this one in, jump over here, come down and along and go through this 2 megohm resistor. That's directly referenced to the mains. That means the input to this microcontroller will be pulsing on and off pretty much at mains frequency. And that gives it the zero crossing point, so it knows how long to time before it switches on the sine wave to actually turn the thyristors on. If it's clever circuitry, it will detect the difference between 50 Hz and 60 Hz. I've missed a value out here. It is 332, 33 and 2 zeros, 3.3K. There are 3 thyristors. I've also not written the value. 2P4M, which is that sensitive gate, probably about 4 amp I'd rate those thyristors probably. And each channel of the LED tape, in each meter there's a series of LEDs in series with resistors, and they get switched by the thyristor to light them up, and the difference between the LED voltage and the mains voltage is dissipated as heat by these resistors, which are spread along the whole run of the tape. In this case, because it's red, green, blue tape, it's got basically, the resistors are alternative, probably doing red, green, blue along it. That's it. It's very simple. You might think that it's odd that there's no diode here to prevent the current flowing back through that resistor when it goes to the 0 volt, but in reality, with 5 volts here, and that's 51k, very little current's going to flow back through that when this is it's at the 0 crossing point and is therefore at 0 volts. And the phase angle control I'm talking about, this the output of this from the rectifier, whereas it's gone AC coming in, alternating polarity, the output is a series of humps like that. This resistor here lets it detect when it goes to 0, when it goes below the 5 volt level, so it knows exactly when it's at these 0 crossing points, and if it says it's to be at half brightness, it will then time up to the midpoint of that sine wave and then turn it on there. It latches on and then it will stay lit for the second half of that half wave. So that is it. Now, I was thinking of doing something experimental. What if you had used some of this LED tape, but you didn't have one of the controllers, but you still wanted the LED tape to light up? I reckon that you could cobble something together. So I'm going to cobble together a bridge rectifier using 1N4007 diodes, one of my favourite diodes. It's the standard 1 amp diode, but with a 1000 volt rating. So to do this, let's zoom down this. Zoom down. Let's brighten it up a little tad and swamp empty screens out. I've got the 2 positive ends going together, the 2 ends of the bands. That's going to be the positive. I'm roughing up a bridge rectifier here. Basically speaking, we're going to drive the LED tape without any control over it. It's just going to be, we can choose a colour from the 3 primary colours, red, green, blue, but we can choose them in a binary multiple. So it could be red, green, blue, cyan, magenta, yellow, or white. I wouldn't recommend using the white though, because it will be driving its absolute maximum power. So I've twisted the other pair of diodes with the non-stripe end, so that's going to be the negative. And now I shall cup them together like this. Notice that I'm actually, because I'm going to be twisting them, I'm actually putting it together like this, and then twisting them together like that. And these are our AC connections. This is going to be all bare and exposed. You could also use a standard bridge rectifier for this. You know, the one that's in a single package. Now I'm going to solder those connections. So, let's solder the negative one first. just basically flow some solder on to tack these together. And then one of the AC inputs. Remembering that with a bridge rectifier, all the diodes point towards a positive connection. This is where, is this one cooled down enough yet? Not really, but it will when I clamp it in my fingers. Ow, 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 ow. It's kind of not cooling. I shall blow in it. That helps. Ow, not really. And then the other AC connection. And then I'm going to whack the mains onto the AC connection. So I shall crop these off. That's hot. That one, it's still hot. And just for reference, the diodes are pointing towards this end. So this is the positive. I shall just slabber it with a Sharpie. And just to differentiate, I'll use blue for the negative, which black would have been better, but black next to black diodes doesn't show up, so I'll use that for the negative. Excellent. Now let's get this cable here, and I shall strip it. Let's actually use a real stripping tool. Wow, not just to use my snips side cutters. Maybe a bit aggressive there, not to worry. I shall, was that the correct one? Yeah, good enough. So we've got that's not blood blue, that's a Sharpie. We shall put the AC onto the AC inputs. So I'll flow some solder onto here. I should have brought the focus up a wee bit higher, but not to worry. I'll try and stay down as low as possible because the focus is technically speaking on the bench at the moment. So there's one of the AC inputs. I shall flow this in a shoddy and haphazard manner. There we go. Just like you should with mains voltage electrical circuitry. And the other one we shall flow onto here. I shall actually do that like that, because then it'll be kind of slightly neater-ish. So I shall flow these together. Since they were both tinned with solder, that is them flowed together. If I get this wrong, this rectifier will go bang. I notice that the plug it comes with says it's fitted with a 13 amp fuse. It also feels very strange, this plug. The plastic is not like a normal UK plasticky plug. I'm just going to take a look inside. It is indeed fitted with a 13 amp fuse. Let's check these are tight. I get the feeling this might not be as compliant as it should be, but then you know that's what happens when you get the stuff from China. You just never know what you're getting. So now we've got our open live connections here when it's powered up. Let's pick a colour. So black is the common positive in this instance. The reason they've done that is it's a fairly standard set of coloured cables, and they're wanting the red, blue and green for the actual colours of the LEDs. I'm just going to check that. Red going to the middle pin, blue going to the middle pin, green going to the middle pin, and black going to the positive out of the bridge rectifier. That is correct. So I'm going to go for a turquoise colour. So I'm going to bridge blue and green together. I shall strip it a wee bit more. And I shall also strip the common positive, which is the black. Very common in the RGB lights for them to use the black as a positive just because it's the last connection left over. I'm going to twist these ones together. And I'm going to solder them. I'm not going to use the red at all. And theoretically, when I power this up off the mains with full wave rectified mains, but not smoothed, it should make this stuff light up turquoisey coloured. Wow, that solder is really not wanting to take to that copper. I may have to add some flux. Is this shit cable? Possibly. Other things worthy of note. The strip along the inside of this LED strip, it's in a channel with little bus bars next to it, and every time it comes to the end of a section, the 1 metre section, little jump wires are jumped from the bus bars. I've featured it in previous videos. I think this is like copper coated aluminium, but I think they maybe just missed off the copper. This feels horrible. Is this just going to pop off? I'm going to add some flux to this. This is vile. This is super proper quality cable here. Let's add some flux Lewis Rossmann style. Add at least 1 micropole of flux. Even then I don't think it's going to go on. This has all gone horribly wrong as a result of this. Let's see if this aggressive extra flux just gives it another bit more bite. No, that is horrible cable. That is vile. How did they even solder that to the circuit board? I'm feeling remorseful about this now. It's just everything's going wrong. That doesn't want to take solder at all. That is just horrible cable. Wow. Rightio, let's just bodge it on anyway. So this one, if it sticks at all, will be going on here. So I'll look for the bit where it looks like a little bit of solder stuck. And I'll splodge it on there. And the positive, I'll kind of just basically, well, the solder didn't stick anywhere in this. It is completely devoid of solder. Let me scrape this with a knife. Scrape, 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 scrape. Is this aluminium? Oh, you know what? Oh, maybe not. I'm not sure what this is. It's not nice. I shall try flowing some solder onto it now and see what happens. Will it take any solder? There's a bit sticking roughly on it, that'll do. It's just to test it. It's the bit that will pop off and touch another connection. Oh, that is just horrible. But then again, it's what it deserves. Okie dokie. So theoretically now with my botched addition, if I plug this in, I'm going to zoom out for this. If I plug this in, let's take it all away from the solder. That would be a really good idea. Double check. That's AC, that's AC. This is positive going out to the black here. Red's tucked out the way. Blue and green are there. It should light up turquoise. Is it going to light up turquoise? No, it's going to light up green. Do you know why that is? It's because it's lighting up the red and green LEDs, and it's lighting up a sort of appley green instead. That's because the blue and green are apparently not the blue and green connections. Excellent. Let me show you what this looks like. Oh, lovely. It's actually not a bad colour. It's an appley green colour. It's quite nice. Not the blue that I was expecting, but I guess that means that these colours are all wrong. So red is not red and green is not green and blue is not blue. Excellent. But you can, by working it out, if you had some of this, you can improvise with just a bridge rectifier, but just watch out for those cables because they're crap. The other thing we could have done here is actually stuff connections up the end of these as well. What colours? There is text up the end there that kind of hints at what the colour is supposed to be. Yeah, very strange. But anyway, that's it. You can hotwire it just to the bridge rectifier straight from the mains with a suitable fuse, but maybe not recommended because, yeah, it just, well, you'd have to enclose it obviously, and it'll work, yeah. That's about, you know, I'd just be cautious about these wires because there's something very odd about the metal they're made of. It's not really, it doesn't feel very coppery. It feels a bit strange. But there we go. Interesting unit. Bit shimmery. It does flicker it between, well, 100 hertz in the UK, 120 hertz in America, but it's about as simple as you could get. And by using this simple circuitry here, it lets them run an absolutely huge quantity directly from the mains, which in some instances is what's required. So interesting stuff, well worth taking a look at and modifying.